Alright, in the final section of this chapter, we can have a look at two examples of flume configuration in detail. The first example is about collecting data from a local directory into HDFS. To use flume, we need to prepare data and download the flume client from MRS Manager. Then we can upload the client into the cluster, and after decompression, we can install it with the scripts provided by MRS Manager. During the installation process, we need to configure the path for installing the flume client, the host IP of the server role, and the path for reading the configuration file called properties.properties. Now, the following several steps are important. Here, we can see the configuration for source, and we can have a look at it in detail. Firstly, we need to configure the names of our source, channel, and sink. Remember, every time we are doing configuration, we always need to specify the name of each component. For example, here we are configuring the source called A1, so we always need to specify A1 in the following steps. This is important, okay? And maybe you can find that we are using spooling directory source or spool dir in short, right? This is because we are monitoring the local file directory for data. And next, a1.file suffix indicates the suffix added to the file after the collection is completed. The suffix indicates that the file has been collected and will not be collected next time. A1.delete policy indicates the policy for deleting source files after file transfer. The value can be never or immediate. By default, source files are not deleted. A1.checkerdir indicates the path for storing the metadata of files collected by flume. A1.ignore pattern indicates the regular expression for the names of files that do not need to be collected in the collection path. A1.batch size indicates the number of events that flume sends in a batch. A larger value indicates higher throughput but higher latency as well. A1.deserializer indicates the file reading mode of flume. A1.selector.type indicates the mode for flume to send data to channels. A1.fileheader indicates the key name of the absolute path of the file where the current event is stored in the event header. A1.fileheader indicates whether to store the file absolute path in the event header. The value can be true or false. And finally, it is necessary to configure which channel is connected with the source by configuring A1.channels. And this is exactly the reason why we mention a source must be associated with at least one channel before. Okay, after configuring source, we can configure channel like this. Here, type indicates the channel type. The value can be file or memory as well. Then capacity indicates the number of events cached in the buffer. The value cannot be too large. It is recommended the value be 10 times of the value of transaction capacity. As for transaction capacity, it indicates the transaction size, that is, the number of events in a transaction that can be processed by the current channel. But please pay attention here. The size cannot be smaller than the batch size of the source data. Otherwise, the events would congest in source and the errors may occur. In reality, we advise you to set the size same as batch size. Channel for count indicates the channel for count. There will be an alarm when the value reaches the threshold. Keep alive indicates the timeout interval for adding or deleting an event in the buffer. Byte capacity buffer percentage indicates the percentage of the remaining buffer memory. When the remaining buffer memory is less than the value of byte capacity, data cannot be sent to the buffer. Alright, now let's have a look at a sink. So in sink configuration, we are using HDFS sink because we need to store data into HDFS. And then we can configure the following parameters for HDFS. Like HDFS.path indicates the writing directory of HDFS, which is a parameter that cannot be left blank. File prefix indicates the prefix of a file after it is written to HDFS. In use suffix indicates the prefix of a file that is being written to HDFS. Row interval indicates the time interval for creating a file in HDFS. Row size indicates the size of a file written to HDFS before a new file is created. Row count indicates the number of events written to HDFS before a new file is created. Batch size indicates the maximum number of events that can be written to HDFS once, and please note that this number cannot be smaller than the transaction capacity of channel, otherwise all events would congest in channel and errors may occur. File type indicates the file format written to HDFS. Max open files indicates the maximum number of files that can be opened in HDFS. Write format indicates serialization mode of the serialized file written to HDFS. The value can be text or writable. Call timeout indicates the timeout interval for operations from HDFS. Thread pool size indicates the size of the thread pool for writing data to HDFS. Fail count indicates the number of consecutive fails to write data to HDFS. File closed by end event indicates whether to close the file that is being written to HDFS based on the source file data. The value is true or false. When configuring options related to row, the value should be false. Otherwise, the configuration related to row will be invalid. And finally, this channel indicates the channel to which the data read by the current sink is sent. This parameter cannot be left blank as well. After configuring all the information, please rename the configuration file into properties.properties and upload it under the same directory as we configured before. Now we can produce data and check whether there is data under the configured HDFS directory. If we can see a file called blah 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 dot completed, congratulations, it means that our processes have been completed successfully. And that is all for the first example. Next, the second example is similar with the first one, but now we are collecting data into Kafka. Because we are still monitoring data under the local directory, the configuration of source remains unchanged. And also, the configuration of channel remains unchanged as well. But now, the configuration part for sink is different. Here, we need to use the Kafka sink, and the following several parameters are about Kafka. Since Kafka will be introduced later, we are not going to introduce them in detail right now. Just know their names, and that is enough for you. Finally, after configuration, we can run the Kafka commands, and then we can obtain all the data under the topic we created before. Alright, that is all for Flume. In this chapter, we mainly introduced the application scenarios and the key features of it, and then we introduced the architecture of it, which is the key point in this chapter. As for the configuration, please pay attention to the relationship between the batch size and transaction size concepts of source, channel, and sink. Thanks for your listening, and I hope you enjoy all the contents in this chapter. Next chapter, we are going to introduce Loader, which is an ETL tool for big data analysis.